Let's solve the given linear inequality. We'll begin by rewriting our given expression as absolute value of x minus 1 divided by x plus 2. So we'll transpose 1 to the left hand side. So we have negative 1, so this is less than 0. Combining the two terms on the left hand side gives us absolute value of x minus 1 minus x minus 2 whole divided by x plus 2 less than 0. Now, in order to solve this linear inequality, we'll have to consider few cases. That's because we have an absolute value here. So let's begin with our first case. So our first case will be case number 1. So in our first case, we will consider that our absolute x minus 1 to be greater than 0. Now, if x minus 1 is greater than 0, we can take it to be equals to 0 as well. If it is, then this means that x is greater than or equals to 1. And when this is the case, we can say that absolute value of x minus 1 will be simply equals to positive of x minus 1. Then our inequality, this is our inequality. Let's label this as number 1. Then inequality number 1 now becomes x minus 1 minus x minus 2 divided by x plus 2 less than 0. So here x and x cancels out. So in the numerator we have negative 3 divided by x plus 2 less than 0. So we need to solve this particular linear inequality. Now we have an expression negative 3 over x plus 2 which is less than 0. I'm labeling this as number 2. Here this value must be less than 0, and we know that negative 3, this is a negative, this is always going to be less than 0. And in order to keep this expression negative, the only possibility is that the denominator must be positive. That means x plus 2 must be greater than 0. Only then we can say that the given expression will be less than 0. So x plus 2 greater than 0 simply means that x is greater than negative 2. So this is our solution. So let's sketch this on a number line. So on the number line we will have negative 2. So if our solution will lie to the right of x equals to negative 2, but x equals to negative 2 is not a part of the solution. So this is the region, and here we also have considered that x is greater than or equals to 1. So we'll have to take into account the fact that the value of x must be also greater than or equals to 1. So here all the values of x will be lying to the right of x equals to 1. Here x equals to 1 is also part of the solution. So this is the common region that satisfies both x greater than equals to 1 or x greater than and x greater than negative 2. So that means our solution will be x greater than or equals to 1. So this is the solution we have obtained from case number 1. Now we'll move upon to case number 2. So in case number 2, we will consider that x minus 1 is less than 0. Since we have already taken x minus 1 is greater than or equals to 0, this time it will be only less than 0. This means that x is less than 1. And in that case, then absolute value of x minus 1, this will be equals to negative of x minus 1 or simply negative x plus 1. Now, we can rewrite our linear inequality as negative of x plus 1 minus x minus 2 divided by x plus 2. So this is going to be less than 0. So negative x minus x will become negative 2x minus 1 divided by x plus 2. So this is less than 0. We'll take negative as the common factor. So we have 2x plus 1 divided by x plus 2. This is less than 0. And what we'll do, we'll multiply both sides with negative 1 to make this negative positive. But in doing so, we have to be a little bit careful here. Whenever we multiply with a positive number, the sign of the inequality changes. And this will become greater than 0 times negative 1, which is simply 0. So our task will be now to find a solution to this linear inequality. So for that, what we need is some critical values. So critical values are defined as those values of x for which the numerator goes to 0 as well as the denominator also goes to 0. So we have x equals to negative half and x equals to negative 2. Now what we'll do, we'll consider a number line. On the number line, we will have negative half, negative 2, that is smaller than actually negative half, so it comes first. Now what we'll do, we'll divide this into 3 regions. So we have region 1, region 2, and region 3. And in each of the region, we'll consider certain values of x, and we will check whether if that particular value of x is going to make our expression 2x plus 1 over x plus 2 positive or negative. So let's do that. So we'll start with region number 1. Let's take a value where x is less than negative 2. So we'll start by beginning by taking x equals to negative 5. You can take any random value as long as it's less than negative 2. So that means we have 2 times x plus 1 divided by x plus 2. So we'll substitute x with negative 5. So we get negative 10 plus 1 divided by negative 5 plus 2, which is simply negative 9 divided by negative 3, and that makes it positive 3. So that means in region number 1, we are getting a positive value. Then what we'll do, we'll consider region number 2. So in region number 2, we're going to consider, let's say, x equals to negative 1. So when we have negative 1, so we have 2 times negative 1 plus 1 divided by negative 1 plus 2. So negative 2 plus 1, so that's negative 1 divided by positive 1, which is giving us a negative value. So in region number 2, we're getting a negative value. And finally, we're going to take a value x equals to 0, 0 being greater than negative half. So here we have 1 over 2, which is giving us a positive value. So we say that in region number 3, we have a positive value. Now, coming to our inequality, we only have to consider those regions where our value is greater than 0. That means positive, and that's going to be region 1 and region 3. So that means we have our x belonging to the region negative infinity to negative 2. So here negative 2 is not a part of the solution. So we'll use an open interval. Union negative half to positive infinity. So negative half is also not a part of the solution. However, here we have to take the condition that x is less than 1. So here we're also given that x is less than 1. So we have one solution that giving x belonging to negative infinity to negative 2 union minus half to positive infinity. And we have another solution, x is less than 1. So that means our actual solution will be x belonging to, so we have from negative infinity to negative 2 union. So we have to consider values of going from negative half, not to infinity, but to 1 only. So this is the solution that we have obtained from case number 2. So our task will be now to combine each of them, each of the solution obtained in case 1 and case 2. So let's do that. So we have the two solution obtained in each of the two cases. For this, now we're going to sketch a number line which will represent all the values of x. So we will start with negative 2, negative half, and 1. So from case number 1, we obtained that x can take all the values greater than or equals to 1. So x equals to 1 is also included. So it is going to lie to the right of x equals to 1 and extend up to positive infinity. Then from the second case, we got the solution that x must lie between negative infinity to negative 2 and also from negative half to 1. So here, if we combine the solution, then our final solution is going to be from negative infinity to negative 2 union negative half. So here x equals to 1 also becomes a part of the solution. That's because we have x equals to 1 from case number 1, and this goes all the way up to positive infinity. So this is our final solution.